Hey, CL Prep Geometry, this is Mr. Allinger, and today we've got some guided notes for section 3.4. It's kind of a short section. It won't be a lot of notes, but you're also going to have some, algebra time that you're going to, use at various times, like because you have the algebra review that's going to be starting up, and so we're okay with a shorter one. So it's section 3.4, and it's perpendicular lines. We've been dealing with parallel lines a lot, and now we're going to talk about perpendicular lines instead. The objectives are up there, and you'll find out about them in just a second. So the question is about how do you find the distance from a point to a line? And so I've given this first one as a pretty easy example of finding the distance from a point to a line. And so probably if you do this, you'd probably just say, okay, well, there's the point there, and go 1, 2, 3, so the distance is 3. And you're right. Woo! All right, math's easy. But now the question, though, is what about this situation here? Now, the trick is, how are you going to measure the distance? So what I want you to do right now is I want you to listen to the instructions, then pause the video and draw a distance. So I want you to draw, kind of like I could draw a segment here to show the distance that's 3 units long. I want you to draw a segment from C to line AB that would represent the distance from line C, from point C to line AB. So draw the line that you're going to use to measure the distance. Have you done it? Pause me if you need to, so that you get done. Okay, so you drew a line, and you could have drawn it in a lot of different places. There's only one right answer on where you draw it, and we'll show you that in a moment. But you might have drawn it straight down to here. You might have drawn it to, I don't know, like about here. You might have drawn it there. I mean, it's like, wait a minute, how do I measure the distance from a point to a line? And so I hope you can kind of see. Get rid of those for a second. I hope you can kind of see why finding the distance from a point to the line and how do you do that is actually a little bit more complicated than that first problem implied. So it's like, well, how am I supposed to know which line I'm supposed to draw? Because you'll actually get different distances depending on how you draw it. The key is to think about this first situation. Why did we draw that line? I mean, after all, we could have drawn like a line like this, or a line like this, or a line like this. We could have drawn all sorts of lines, segments, I guess, to find the distance. But it was really obvious that that was the distance right there. And so what you want to think about is, well, what was special about that line? You could say two things. You could say it's the shortest distance. Right? You could say, well, you're supposed to go the shortest way. But then that might be kind of tricky when we go to the second problem, because on the second problem, it's like, well, how do I find the shortest way? It's not as obvious as it is in the first one. And then the second thing you probably notice, if you think about what's special about that line that's different from all those other lines, is that line is perpendicular. And so this is the key idea here, is that it's the shortest distance, but also that it's perpendicular to the line. Remember, we're going to be using this abbreviation for perpendicular. I'll write it this one time, but from now on, I'll just write perpendicular. A little meaning perpendicular, and just like we do the for parallel. Yeah. So it's got to be perpendicular to the line. That was why that segment I drew in the first one made so much sense. And so that's what I need to do, is I need to find which segment here would be perpendicular to that line. Now, you can kind of eyeball it. If you sort of take your surface, this is probably going to be kind of funny, and kind of tilt it a little bit, So right now I'm tilting my surface so it looks straight up and down. So the line is horizontal in my vision. And so I can kind of imagine where the segment would be. And so I can kind of see, well, it's kind of going this way, something like this or something like that, is what it kind of looks like when I just kind of eyeball it. But that's still kind of vague. And so we need to be a little bit more specific if we're going to do a good job with this and just not have to eyeball everything. So how are we going to do that? Well, you need to know a key idea with perpendicular lines, is that perpendicular lines. So let's see, how would I know which line was perpendicular to this one besides the 90-degree angles and stuff? And the big thing that you can do is you can use slopes to do it. So think about this line. This line here has a slope of 2 over and 1 up. So the line we have, the slope is 1/2. Now the question is, okay, so what's the perpendicular slope to this? And you might think, well, what if I made a line through this one? I'll change color here, go blue. And what if I made a line through this one that has a slope of -1/2? Because if one's going up, then perpendicular should be going down. That makes sense. And so I could make a slope of -1/2. And so I could go like boom and boom and slope equals -1/2. Does that look perpendicular? Does it look like 90-degree angles? Not to me. That can't be right. So, and if you think about it, like if you have a slope of like, remember that positive slope, negative slope, and small slopes are around 0. So like what if you had a slope of like 1/10, like really flat, just a little tilted, and a slope of -1/10? Those aren't making right angles at all. Like if one slope is really small, then the perpendicular slope has to be really big. If one slope is really flat, then the perpendicular one is going to be really steep. So the slope can't be like also small and -1/2. That's nope. What we need to do is we need to not go down 1/2. We need to go down 2/1. Down 2/1. There we go. There's that one. We need a steep slope. And when I draw that one, then it's like, ooh, hey, that looks like kind of perpendicular there. So we need this slope to be positive, because it definitely needs to be the opposite sign, but it also needs to be steep. And it turns out the slope we need is we need to be -2/1. So this one was not correct. I tried that. That was kind of the obvious idea, but it looked wrong, and I could tell it was wrong. But now when I go 1/2 and -2/1, I look at those and I go, wow, that's totally perpendicular. So now we could measure the distance. So perpendicular lines, the big thing is that they have slopes that have different signs. So you got to change the sign if you want to find the perpendicular slope, and flipped. So if you want to take one slope and you want to find the perpendicular slope, you have to change the signs, right? But you also have to make it so that it flips upside down. So if it's like 3/4 over here, it has to be -4/3 over here. And so I have to flip them and change the sign. There's a shorthand way to say this, which is to say that they are opposite reciprocals. Reciprocals means flipped, and opposite changes a sign. Cool. So now we know how to do this. And now we could find the distance between this point and this point. We can't just count boxes like we did before, but we can do distance formula because now we have 2 points to measure. And that's what made this problem hard. When you see a point and a line and you're trying to find the distance, it's hard because you're like, I need 2 points and I can find the distance between 2 points. But right now I only have 1 point. So that's what the whole perpendicular thing helps us with, is it helps me to draw a line so I can see where that perpendicular line hits the line I'm working with. And that way I get a point and I've got 2 points. I've got this one here and this one here. And you can find the distance between those any way you want to. Why don't you pause the video right now, and why don't you try to find the distance between those 2 points. I'll give you a second to see what you remember. You can pause it if you remember some stuff and you're going to do it. Now, if you're getting totally refreshed on this, you need to start working on practicing that and remembering it and making sure you got it. So distance between 2 points, you can do it. Remember, you can do it with Pythagorean theorem, or you can do it with the distance formula. Students know that I always do the Pythagorean theorem way. Like I do it unless the numbers are really weird. Like if the numbers are really weird, sometimes I use distance formula. But otherwise, I say, all right, I'm finding the distance between these 2 points. Well, it's 1, 2, 3, 4. It's 4 down and 2 over. So 4 squared plus 2 squared gives me the distance squared, right? Because of Pythagorean theorem. And so that's 20 is the distance squared. That's 16 plus 4. Whoop, sorry. And so square root both sides. And the distance is the square root of 20. Can I simplify that? Why don't you take a practice one? Simplify that. You'll have to on the test. So, all right. And again, I do it the break into square roots way. So I go square root 4, square root 5. So I get 2 root 5. If you do it the factor tree way, then that's great. You get the same answer. Okay, now it's time for you to do one. And so I want you to find the distance from point C to line AB. And the way you're going to do that is by figuring out what the slope of AB is. And so then figuring out what the perpendicular slope is. Right? So you know what slope to make. And then make that slope from point C. So 1, 2, 3. You don't have to write a number here, but like draw whatever that slope is. I don't know what it is right now, but draw that slope so that you can see where it hits, and then find the distance between the 2 points. So this problem is kind of nice because it uses slope, it uses distance formula. I mean, it's nice from a teacher perspective, and it uses and it uses this new perpendicular idea we have that now we know. And so remember, this is their thing is to find the distance from a point to a line. Now we know that in order to measure the distance from a point to a line, we have to travel perpendicularly between them. And when we hit the line, then travel perpendicular between them. I was going to say something else about that. Oh, and to find the perpendicular slope, we do that opposite reciprocal thing. We take one slope. If we want to make a perpendicular slope, we change the sign, but then we turn it over so that if it was flat, it becomes steep. If it was steep, it becomes flat. And that way they'll be perpendicular. If you just change the sign, it won't be perpendicular. Okay? So you try it, and at the beginning of the next video, we'll show you the answer so you can make sure that you got it right. I'm going to stop this one here. Good luck.